Let's get started with a function review. In pre-calculus and other upper-level math classes past pre-calculus, understanding what a function is and how functions work and how function notation works is very crucial. You've had this before probably in previous classes, or at least parts of this before, so we're just going to do a quick recap to make sure everything's fresh in your mind. So first of all, what is a function? I have a picture of a function here. This happens to be a quadratic function, which makes a graph called a parabola. In a function, each x is paired with exactly one y. Another way of saying that is that each input is paired with exactly one output. We can see this on the graph because we can see if we go to our input values would be our x values, and we can see if we go up from every x value here, we see that each x value has one unique y value that goes with it. We can also see this in the table of values that each x pairs with exactly one y. There aren't any duplicate x values that have two different y values. So we say that this mathematical relation is called a function. So we're going to look at four graphs and determine whether they or not they are a function. Now you may have heard of something called the vertical line test for a function. And the vertical line test for a function is a valid test for functions involving x and y. But we're going to be learning about some other types of functions this year, primarily second semester, that do not are not graphed on an xy plane. And so I want to get away from that definition strictly of a vertical line test and think more of each input has exactly one output. So let's look at our first function here. Does each input have exactly one output? So let's just look at one input, for example, 4. If I use 4 as my input value or my x value, notice that I get two different outputs. So we would say no, this is not a function because x equals 4 has two different outputs. Oh my word, that's pretty bad the way I wrote that. Let me try again. Because x equals 4 has two different outputs. 2 and -2. So it is not a function. Now, if you look at the graph up here, this is the graph f of x equals x squared, or we could say y equals x squared. This graph happens to be x equals y squared. I can't use the f of x notation. We'll talk more about notation in the next video because it's not a function. So this happens to be the graph x equals y squared. Not a function. This next graph, does each input have only one output? So if I take each x value and find the point on the graph that goes with that x value, there's only one point on the graph for each x value. So yes, this is a function because each input has only one output. Now, if I were to ask you, is such and such a function, I would want you to be able to explain to me using the definition of the function that's in the box up here, why or why it is not, why it is a function or why it is not. So make sure that you can actually put that into words. Next one, is this a function? Does each input have exactly one output? This is a little trickier because we notice if we were to actually figure out the coordinates of these points, let's start at this point right here. This is the point -3, 2. This is the point -2, 2. Oh, sorry. Putting those points in the wrong spot. -1, 2. 0, 2. 1, 2, 3. All of those 1, 2, 2, 2, 3, 2. And we see that these numbers here in the y column are all the same. But let's think of the definition. Does each input have exactly one output? So when I put -3 into the function, do I get two different outputs? No, I just get two. When I put -2 into the function, do I get two different outputs? No, I just get two. So having all of the y values the same is not a problem as long as each x value only has one y value. So yes, this is a function. Same reason. Each input has only one output. So it is a function. This function, if we look at this, and actually I'll wait for a minute to talk about the equations of this function. Now when we go to this next one and we look at these points here and make a little table of values for x and y. So notice, let's start with this top point here. This is the point 2, 2. And the next point is 2, 1. And then we have 2, 0. And then we have 2, -1. And then we have 2, -2. So here all of the values in the x column are the same. So that means the number 2, the input, has a multitude of different outputs. In fact, it has an infinite number of outputs. So we say, no, this is not a function. The input x equals 2 has multiple outputs. In fact, an infinite number of outputs, if you extend the line all the way up and down. Now, students sometimes mix up the equations of a horizontal line and a vertical line, thinking the horizontal line is parallel to the x-axis, so it's something like x equals, but it's not. If you notice, what is the defining characteristic of this function? It's that y always equals 2. So this has the equation y equals 2. The defining characteristic of this graph is that all the x values are 2, so this has the equation x equals 2. Without a y coordinate in the equation, it's not going to be a function. X equals 2 is not a function. Y is equal to 2. I could also say f of x equals 2. That would be another way of writing the equation of the function. And we'll talk more about notation in the next video.